Hello friends, welcome to Civil Engineering exam. Today we are going to see the problem related with soil mechanics, the topic of soil water. So the problem is the water table in a deposit of 8 meter thick is a depth of 3 meter below the ground surface. Above the water table, the sand is saturated with the capillary water. The bulk density of the sand is 19.62 kiloton per meter cube. Calculate the total pressure, pore water pressure, effective pressure at the depth of 8 meter. Okay, so now we can draw the layer. Okay, so there is a layer of sand layer 8 meter thick. Okay, so this is the ground surface. So the water table is lies 3 meter below the ground surface. Okay, so here is the water table. So here is 3 meter, then here is 5 meter. Okay, so the above the water table, the soil is saturated with capillary water. So the same gamma saturation and gamma saturation over there. Okay, so the here the gamma saturation 19.62. So here also the gamma saturation value is 19.62 kilonewton per meter cube. Okay, so now we have to find out the total stress, that is sigma, then pore water pressure, then effective stress at the layer 8 meter depth. Okay, so here we have to find out those things. Okay, so in this case we have to remember two things. So the first one is we can see above the layer, so whatever load is there, so everything is based on the above the layer. Okay, so if second thing is if we find out the mu value, so in that portion, in the ground portion, so there is a capillary force over here, so we can put the minus gamma w. Okay, so two things are very important to solve this program. So now we can take here is a and a. Okay, so now the total stress at AA, so the AA layer we can take the total stress equal to gamma saturation into H1. Okay, so this is the H1 value. Okay, so now the gamma saturation into H1, so we can take both cases. Okay, so now we can take 19.62 into total is 8 meter. Okay, so now we got the value of 156 kilonewton per meter square. Okay, so next thing is mu value. So mu value is gamma W into H2. Okay, so this is a H1 value. Here is H3. Here is H2. Okay, so there is a water in the H2 portion. So now we can put the H2 value. So that is 9.81 into H2 value is 5 meter. Okay, so now we got the value of 49.05 kilonewton per meter square. Okay, so next thing is sigma dash value, so that is sigma minus mu. Okay, so the total stress is sigma dash effective stress plus pore water pressure. So now we can take this sigma dash equal to sigma minus mu, so that is equal to 156 minus 49.05, so that is equal to 107.91 kilonewton per meter square. Okay, so this is a simple method we can solve the problem. If case we can take the BB. Okay, so if case we can take the layer of BB, so the first condition is we can see the upward force, so upward direction. So if case any load is there. Okay, so if case we can take the BB layer, so now sigma value is 0. Okay, so there is a no force above the B layer. Okay, so next thing is mu. So if case the soil is saturated with the capillary water, we can put the negative value, so till the water depth. Okay, so now we already see that, so minus gamma W into H3. Okay, so minus 9.81 into H3 value is 3. Okay, so solving this we got the value of minus 29.43 kilonewton per meter square. Okay, so next thing is we can find out the effective stress, that is sigma minus mu. So the sigma value is 0 minus minus of 29.43. Okay, so solving this we got the value of positive 29.43 kilonewton per meter square. Okay, so this is a method we can solve the problem. Again, we'll see in video. Thank you.